Hello, everybody. Welcome to today's webinar. We are going to be looking at a lot of pandas and Python today, trying to get more work done more quickly in data analysis. This is the second webinar that we've hosted on using pandas more effectively. If you're interested in the first one and you didn't get a chance to see it, I'm going to drop it in the chat on Zoom and also the chat up on YouTube. My name is Alex Chisholm. I'm the co-founder of DataQuery. I've been in the data science space for the last 15 years and am currently working full-time in product management for an online data science SaaS product. I am joined by my co-founder and colleague and friend, David Sponsor. David, can you hear us today?
I can hear you. Good morning, everyone. Can you hear me?
Perfect. I can hear you just fine.
Okay.
We had some video issues this morning, so for some reason I'm not able to let David turn on his camera, but I think that's okay because we're going to be sharing just a lot of code in general.
Oh, so I did my hair for no reason this morning.
Right, and I didn't do mine, and maybe I should have been the one that did it. So today what we want to do is just again look at these. They're not even really, in many cases, not new features, but thinking and trying to build up some kind of philosophy for approaching interacting with data. So, right, anytime that we're going to start an analysis, we're going to go identify a data set. We need to connect to it. We've got to find a way to pull out relevant information. We're going to do our analysis. And then most likely you're going to find yourself repeating these steps, maybe with different variables, maybe with an updated data set. Maybe you just need to slightly tweak the type of analysis that you're running. So setting up the workflows of useful steps is really critical so that you can have not just a reproducible, but an easily reusable and scalable approach to working with data. So David has put together a lot of good information in this data or Deep Note notebook. I'm going to share the link to that in both the chats as well. And I'll follow up with people who registered for the webinar with links to all the resources here. But if you have any questions along the way, please feel free to drop a question into the box, again, on YouTube or on Zoom. And I think with that, I'll just pass things over to David to get started.
Awesome. Thanks a lot, Alex. So today, as Alex mentioned, it's really important as you start to use pandas in your daily work, you're going to run into these what some people call design patterns. There's things you reuse over and over again. There's just patterns of data analysis. And so today we're just going to focus on what I'm calling these data analysis workflows and specifically method chaining. So that's what the technique is known as. So you have multiple benefits with these techniques. It allows you to organize your code in a nice, readable manner. And that's very important as you're doing data analysis as well. Because if you have colleagues that are going to be taking over your workflows, it's important for them to see your code and be able to quickly understand exactly what's going on. All right. So the cleaner you can write your code, the more concise, the better it will be for being able to reproduce it and pass your work on to other colleagues. And also, it's easier to see the patterns of what you're doing when you use method chaining, right? You can clearly see all the steps that you're doing. And if you need to tweak just one aspect of your pipeline, it's very easy to do because you know exactly where to go to. So this will make more sense as we see these examples that we're going to go through. I just wanted to give you that introduction as to what we're going to be focusing on today. So here in this first cell, we're going to, as usual, just set up our notebook environment here. This code I use pretty much in every notebook that I ever write. It allows you to print out multiple output from a code cell, which is very helpful. And then here we're just importing our pandas, data analysis library, also NumPy. And then for data visualization, we're importing our Matplotlib and Seaborn, although we're not going to be using that today. All right, so here we're going to be loading everything up. And we will again be working with the employee data set. So we worked with this in our last meeting, but just to recap. So here we have over 1,000 employees at a particular company. We have whether they left the company or not, and all sorts of attributes about these employees, such as their department and salary and their performance reviews for that particular year. So this is from the field of HR analytics, where companies really strive to optimize employee experience. So they really dig into these type of data sets to see where they can optimize, things at their company. So just a quick introduction to what method chaining is. So imagine that you have this data set and that you're an analyst at this company. And let's take a really simple example of something that you would want to do on this data, to take it from this raw data that we just loaded as is, and you want to do these transformations here. So I've outlined them here in these 4 steps. So let's say you want to load this data set and you want to subset it to only include senior managers and directors. So step 1 is going to be some sort of a filtering operation where you're selecting certain rows of the data to keep. Then number 2, you want to keep the following columns. You just are interested in whether they left the company, their department, their salary, and also their performance rating. So this would be how well they did on their annual performance review. And then the third thing is you want to sort the resulting data frame by department and salary in ascending order. And then finally, you want to reset the index to go from 0, and incrementally increasing by 1. So let's say you want to take just these 4 steps. So the first thing I wanted to show you is how would you do this without method chaining? So you would have to have these steps in their own code chunk and just execute them one after the other. And again, there's nothing wrong with this method. It just leads to a bit more code, and you are saving all of those temporary results in a data frame as you go. So for step 1, so here we're going to be subsetting those rows. So here we're interested in only senior managers and directors. So we're going to be creating this new data frame. I'm calling it Senior Manager Director DF here. And then I'm going to access my employee DF and then use this query method here. So this is what we covered in our last meeting. So this allows you to pass a string so that it gets evaluated. And it's very much so just like a SQL where clause. So it's very easy to kind of understand what's going on here. So here, my query is job level. So that is the variable that we're interested in. And then the keyword in. And then I pass senior manager and director inside of this tuple with quotes around them. So that's going to subset our data just to include that particular role, right? So here I just see senior managers and directors now in my 3rd column. Okay, so we have step 1 complete. Right, so we have it saved into this new data frame. Now, step 2 is we're going to have to do a filtering operation again, but this time on our columns instead of our rows. So for step 2, I can simply take what I have already created, my senior manager director DF, and then use the filter method and select the columns I'm interested in. So here I have a list of the columns that I would like to keep. And then I simply specify that the axis that I'm interested in subsetting is 1. So that stands for your columns there. So here I'm going to filter that out. And then we're going to see that we're going to update our results now. So that step 2 is executed here. So now I have all of these columns that I'm interested in. And then for step 3, I would like to sort the values by department and salary. Right, so here, if I look at department, I want to sort those in alphabetical order. And then after that, within each department, I want to sort the salary in ascending order. So with this, I could use another method in Pandas that works with data frames. So I can simply take my senior manager director DF that we've created that has just those columns we're interested in. And now I pass this sort values method. And here I specify by and my list of department and salary. So this will sort our results just the way we would like them. So now you can see I have only people from finance and operations, and I have their salary in ascending order. All right, so we're almost done. So the very last step is to reset the index. And you can see that the index currently in our data frame, it starts with 1,241. So that means that was the original row number in the raw data, where this particular row is now after it is sorted. So we want to reset that and set that again to start with 0 and increment by 1.
Hey, David, I've got a question for you. I find that reset index is one of the things that trips me up the most because it leads to these errors later on that you're not really expecting. Is there a way to make that happen by default when you do something to a data frame?
Unfortunately, no, it will not do it by default. You can use the reset index method in place if you want to do it, to pipe it into your workflow, but it won't do it by default. And I agree with you, that can lead to some issues. And I run into those often where you do have to be careful in Pandas, unlike in the tidyverse, when you compare it with R, there's no index there in R data frames. But here we have those. So that really can make a difference. So I guess the situations where you would not want to reset an index would be if you're doing machine learning, for example. If you're splitting your data into a training and a test set, and then you fit a model, and then you want to predict on a test set. So there it's really important to keep the index as it was, because maybe your index would be something like a customer ID or some kind of an identifier. So there you want to make sure that you're making the right prediction for the right store. So you don't want to accidentally reset. So in those situations, I usually leave the index as is. But then sometimes in these situations where you're creating a new data set that you're going to be using for something completely different, that's where I will reset it just to keep it consistent in case you're going to be doing more, maybe group by aggregations or things like that in the future.
Makes sense. Thank you.
And then this final step is this resetting. I just wanted to show you what it does, but you simply take this senior manager director DF that we created, and then you use the reset index method, and you specify drop is equal to true. If you don't leave that as true, if you keep it as false, it's going to take the original index that exists and turn it into a new column. So that is also another option. If you wanted to keep the original ordering of rows for some reason, you could do that and add it as a new column. But here we just decided to drop it. And now we can see it starts from 0 and goes to 1. So that's a unique identifier for the row. All right, so that was a lot to go over, just 4 simple steps. And you can see that we had 4 different code chunks, and we're taking these different steps. So it would be definitely a lot easier to read, and I think easier to understand if we were able to put this together into just a single workflow and just separate each one of these steps by a new line, for example. So there's a couple of ways we can do this. So with method chaining, you could use a backslash and connect all of these various methods. And that's what I'm showing you here in this workflow here. And so here, what this code is doing is it's starting with this employee DF, and then I can add a backslash so I can move to the next line. And typically you will want to start the dot and then the particular method on the new line. So here I'm using the query method. So same query as before. So up until this point, now we're going to get a data frame that's been filtered for just senior managers and directors. And then I can add another backslash and then use another method on that result, right? So here, this is going to be passed. The result of this query will be passed into this filter method. And here we select our columns of interest, and then we pass that result into sort values, right? This is where we use the other method where we want to sort by department and salary. And then finally, we reset the index. And so we're going to get the same result here that we got before. But the benefit is that now we have all of our steps laid out on individual lines, and we don't have to save any intermediate results. So we don't have to create this data frame here and keep updating it along the way like we did before, right? So that's one benefit of it. So you don't have to eat up as much memory by creating all of these intermediate results. And it's also much easier to read. So you can see what's going on here. So this is when people say method chaining, this is what they mean. So they take a data frame, and then you can stack methods on top of it, and you can keep going as long as all of these methods take as input a data frame. So you can chain as many of these as you would like. But another thing I will mention here is you don't want to go overboard. So you don't want to do something like chain 50 methods all into a single expression to get your final result. Because then if you get an error in that very long workflow, sometimes it's difficult to figure out where that error occurred in those 50 steps, right? So you do have to balance that. So you're wanting readability, but you want to make sure that you can also catch errors easily if they occur, right? So typically I don't like to chain more than 10 commands into a single workflow, just to watch out for errors. All right, so that's what method chaining does for us. Very easy to read. Now, there is a different way to do this that I prefer, because here we have to add all of these backslashes. So again, that's a lot of extra typing that you have to add after every single line. What you can do instead is you can enclose your chained operations inside of a set of parentheses. If you do that, then you can start a new line by default. You don't have to put a backslash anymore. So here I'm saving the results. I'm calling this method chaining, although I misspelled it. I'll fix that later. Method chaining df. And I'm setting it equal to this chained method sequence here of expressions inside of these parentheses. So again, this will do exactly the same thing that we did before. It's going to save our results into method chaining df. And here we can just make sure that we do get the same thing. All right, so now we're good to go on that front. So typically, if I'm doing data analysis or maybe feature engineering for machine learning, I have a lot of these sequences of workflows. So I separate things out by, all right, so in this step, I'm going to be processing my numeric variables, for example. So I will process them with these chained expressions, and then I'll move on to my categorical features maybe, and so forth. So your typical analysis workflow is these sets of these workflows that are chained together, and it's very easy to see what you're doing. Now here, I wanted to show you some examples of how method chaining is used. So we're going to build on top of this example a little bit, and just a preview of the things to come. So in our next meetings, which I'm sure we'll be doing in maybe about a week or two, I'm going to focus in depth on each one of these methods. So the first one that we're going to be showcasing is called assign. And there's also another powerful one. It's named pipe. So these are very powerful. And when you put things together with method chaining, you can do some really complex things in very few lines of code. That's very readable. And again, I just did want to mention, if this is confusing, right? If you've never heard of assign or pipe, that's okay. So here we're just showing you what's going on, but we will go in detail next time we meet for every single one of these. So you're going to become very good at these when you put it together. And so here, I would just like to show you, if I'm using assign is used for creating new columns. So let's say that we wanted to create 2 new columns into this data frame that we created here, this method chaining data frame. All right, so I want to create a column that's derived from salary. And so here I could use assign. So I want to show you how this works. So after I have selected my columns using this filter method here, I can then pass it into this assign method. And here, the syntax for assign is on the left-hand side, you write what this new column that you're creating, what you would like it to be named. So here I'm creating high earner and then positive review. I'm creating these 2 columns. And they're going to be derived from the salary column and then the performance rating column. So here I have an empty cell just to show you what these are doing. So here I'm using NumPy and p.percentile. So for this one, I'm calculating the 75th percentile of the salary column in my data, right? So this is going to return some kind of a number for me, right? So here I have about $117,000. That's the 75th percentile. So this gets evaluated to that particular number. And then here I'm saying employee DF, and I'm subsetting salary. So I'm taking that series outside, I'm pulling it from my data frame, and I'm testing where is that value greater than or equal to this particular value, the 75th percentile. Now, if I execute this is going to give me a Boolean series. It's going to give me a set of values that are just true and false, that are going to be the same length as the salary column. And you can see I get a sequence of trues and false where that condition is met. And then finally, I'm enclosing these in parentheses here. This is another trick that we'll go over in detail in coming sessions. You can capture that series of trues and falses, and then I can say dot as type, and I want to convert it into an integer. So here it's going to take my trues, turn them into a 1, and take my falses and turn them into a 0. So this is kind of a shortcut for creating these. They're known as indicator variables or dummy variables, where a condition has been met or not. All right, so that's what I'm doing inside of this call here. So high earner is going to give me 0s and 1s for that condition. And then for the positive review, I'm simply taking where the performance rating, and I'm using the method is_in, meets expectations, exceeds, or exceptional. So this means somebody did really well on their performance review. And again, this is going to give me trues and falses, and I'm turning it into an integer type. All right, so that's going to create those 2 new columns in this step. And then I'm going to method chain the result, and I'm going to use the drop method, and I'm going to drop the original performance rating. And so that's all I've done. I've just added this single step into this pipeline. It's relatively easy to do once you have things laid out like this by line. And then you can see that all we have to do is make a change here in the middle to maybe add some columns, and you can see that everything still works. All of the steps are executed in the same logical order. So now
David, we've got a question coming in on that whole method chain. If you wanted to turn this into a function that passed in specific variable names, is it as simple as just naming those within the function and passing it through your employee DF on your assign lines?
Yes, yeah. So with that one, I would automatically start to think about using F strings, and those are common in Python. So anytime you do a string and then you put an F in front of it, you can access variable values, right? So here, if I do F, and then I do let me set calls equal to something. Right, this is a way to pass strings into code in Python. So if you did want to write this function, you would just have to label each one of these columns, or actually even a list. So I would create a list here for what I want to filter. So I would call it maybe my filter list. And then here you would use this F string to pass that dynamically into this function. And then same thing for any variables you want to create here, right? So you would simply just have to label them in variables and then go ahead and pass that as input into your function. So you can do things like that pretty easily in Python.
Great, you got a big thumbs up.
All right, so hopefully this showed you kind of the power of how you can do this. If we compare it to what we did before, where we had things in separate code chunks, you would have to really understand what each one is doing and go and change one particular one and make sure all the other ones work. But at least when we have everything chained together here, you can simply add a step and see if it works right away. Just run the whole pipeline and make sure you get consistent results. Now, again, if that was confusing, that's okay. We're going to focus on that the next time around. And I'm going to show you all the possible ways you could use assign and actually how powerful that method is. And I wanted to conclude today with one of my favorites. This is known as the pipe method. And I think it's the best kept secret of Pandas. I don't know why everybody doesn't use it, but I use it almost every day. I think it's amazing. But here is a problem I'm going to pose here. So if we look at this pipeline here, I'm using assign again. I'm creating high earner and positive review, just like last time. But let's say I wanted to create a new column that is based on those ones I just created, right? So this is also another common pattern, right? So I take this high earner positive review. Now, how can I combine them after? So I could try to do this within assign, right? I can say top employee and set it equal to, and I'm going to try to subset this employee DF high earner and multiply it by positive review. So what this is going to do is if somebody has a 1 in both of those columns, you're going to get a 1 and a 0 otherwise. So I want to identify people who do well on their reviews and earn a lot in their salary as the top performers here. But I'm going to get an error here when I try to do this in assign. And this is typically kind of a shock, especially for people that are coming from the tidyverse world in R, because using mutate in R, you can easily do this. You can create new columns, and then you can reference them within the same mutate call, just like this. You would expect this to work. But in Pandas, this does not work because there is no high earner in employee DF, right? Because it hasn't been created yet, because the assign method has to finish and it gets created after it gets completed. So we can't access it here. So how do we get around that? So it's as simple as taking what we've done here with assign and then using the pipe method. So what pipe does is it takes that data frame and those 2 new columns we've created as this intermediate result, and it passes it into this pipe method. So now we can actually access those things that we've created. And so here I'm writing what is known as a lambda function. So this is just a syntax for quickly writing functions on the fly. And so think of this as a function of df. So this is what is being piped into, which would be the evaluated method chain up until this point. And this is going to be piped into, and I'm calling it df. And now I'm saying df dot assign and create this new column, top employee. And now I can access these columns that have been created, right? Because they have been piped in using this pipe method. So this is the secret of how you can chain multiple things together and also, use intermediate results from assign as you work your way through your workflow. Now, again, if that was confusing, that's absolutely okay. We're going to spend a whole session on pipe and all the different things you can do with pipe. But I just wanted to show you that all of these things are possible. So if you're coming from the world of the tidyverse and R, and you're used to doing things in these workflows, you can do it also in Pandas. You just have to know these tricks and these special methods that will help you out to stitch things together. And as you can see, things worked out really well here, right? So now I have my top employee column that I was able to create that is based off of these high earner and positive review columns, and everything works. So finally, if we put it all together, now I'm adding my drop performance rating, I'm sorting my values and resetting my index. Now I've got my whole entire workflow, right? So let's say that this was your job, right, for this particular task, right? Take the raw data, clean it up, sort it, and create these new columns for me, and maybe pass it on to a dashboard. All right, so you can simply save it as this nice pipeline that you have together, and you can clearly see what each line is doing. And it's a bit easier to debug in the future And it's definitely easier for people to see what you're doing, that they can look at every single line and see all the steps that you're taking. All right, so that was our quick introduction to method shading, and hopefully I've convinced you that it's worthwhile to learn how to do this and structure your code this way. And in our next sessions, we'll be doing deep dives on all of these different methods and all the cool things you can do with them.
And if anyone has any questions now for David or myself, or are interested in shaping future sessions that we run, feel free to drop us a note here. You can also reach both of us at either Alex or David at dataquery.com. David, do you want to pull up dataquery.com for a second?
Oh, sure.
For those that don't know dataquery.com, it's just a listing and an aggregate of a bunch of different resources for training opportunities, largely free. But if you were just to type in, for instance, pandas here, we'll come back and we'll be able to see just how many courses we have specifically on pandas. And I think it's around 50 or so. So you can go through and you can find out, different length courses, free, subscription, certificate, degree, all of that good stuff. And we totally recognize that there's so many different ways that you can learn data science today. And one day it might be a live workshop. One day it might be a course you follow through. And the next day it might be an open textbook online. And they're all fantastic. And we know that both experience learning and experience doing are the best way to get proficient with these tools. So we encourage you to check that out. And we hope you all follow up with us at future webinars and events so you can get more proficient and more fast and more enjoyment out of working with data and being able to translate those insights into business decisions. So with that, I think we'll take off for the day, as I don't see any more questions coming in right now. Thanks again. Enjoy the weekend, and we'll see you next time.
All right. Thank you, everybody.
Thank you, David. Yeah. Bye, everyone.
Bye.